Hello and welcome to this lesson about number of solutions to equations or inequalities. The learning target for this video is knowing how many solutions there are to an equation or an inequality. So let's talk about when is this going to happen. There are a couple of cases, or a couple of cases that we need to keep in mind, and a couple of other details. So first and foremost, it's when we have lots of variables. And I'm talking about lots of the same variables. So lots of x's, lots of y's. We're not mixing x's and y's, but just lots of the same variable. You might need to combine some like terms. You might have variables on both sides, but it could happen when this is the case. Really, when it happens is when variables cancel each other out. Variables cancel each other out. And you're only left with numbers. Then the other thing that we really need to consider, and this has nothing really to do with when does this happen, but the big question is, when all this happens, is it true or false? And you'll see what I mean by that when we get to some examples. Now, let's talk about sort of the situations that we get here. So we have essentially three main situations. There we go. So three situations when it comes to how many solutions you're going to get. All right, we have one, none, all. So these are the three possibilities. Now, one, this is what you're going to get like 95+% of the time. X equals 2. X is less than 2. And that's why I put 1 in quotes there, because there's more than one solution to x is less than 2. But that's the answer right there. All right, you have an x, you got an equal sign, you got an inequality, you got a number on the other side. That's what you end up getting. Now, none is when the x's or the variable cancels out, and you get something that looks like this. You have 0 equals 1. You have A equaling B, two numbers that are equal to each other that are not the same number. Or if we're going to use numbers again, let's say we had 0 is greater than 1. What we have here is a series of false statements. So these are all false. 0 is not greater than 1. 0 does not equal 1. And if that's the case, we have no solution. And then the third case is where we're going to have all the answers. And this is what happens when you get 0 equals 0. You have the same number being set equal to itself. This also happens when we have something like 0 is less than 1. So notice the difference here just by focusing on the inequality, how that's changing things a little bit. Now that we have 0 is less than 1, these are all true statements. 0 less than 1, 0 equals 0. And so this means that our answers are all real numbers. And we use that fancy R for that. So all real numbers, because all real numbers can be an awful lot to write. So all real numbers. So now let's take a look at some more specific examples with equations and inequalities. So for an equation, let's say we have something like this. So here's our first example. 5x plus 2 is equal to 6x plus 7 minus the quantity x plus 2. So here is what I was talking about. We have lots of variables. We have three different variables. And we got to combine them. We're going to have to move them to both, or they're on both sides of the equation. We've got a lot happening here. Now, again, most of the time, you'll just get a normal answer, x equals something. But here, we're not going to get that. So if I distribute my negative sign, I'll have negative x minus 2. On the left-hand side, I still have 5x plus 2. And now I start combining my like terms. 6 and negative x is 5x. 7 and negative 2 is going to be plus 2. Right here, warning bells should be going off in my head because I'm seeing the exact same thing on both sides. And if I continue the process of solving, subtracting 2, subtracting 2, subtracting 5x, like I was trying to solve for x, I end up getting 0 equals 0. So this is where I have to ask myself, is this true or false? And this is a true statement. If that is the case, because the variables have canceled out and I'm left with two numbers equaling each other, that means that my answer is all real numbers. Now, let's compare that to something like this. Let's say I'm dealing with 4 times the quantity, 3x minus 5, is equal to 2 times the quantity, 6x minus 1. I distribute, and I have 12x minus 20 equals 12x minus 2. Again, warning bells should be going off because of the 12x's. They're the same thing. And when I subtract 12x from both sides, I have 0x, and I'm left with negative 20 equals negative 2. And so the question, again, becomes, is this a true or false statement? It is a false statement, so my answer is no solution. Okay? Now, let's take a look at inequalities. So for inequalities, again, I have to stress this idea of true or false, because that's really what you're looking at. Is it true or is it false? And so let's take something like 9x plus 2 is less than or equal to 3 times the quantity, 3x minus 4. I'm going to go about solving it. So I still have 9x plus 2 on the left. I do my distribution. I'll have 9x minus 12. Again, warning bells should be going off because I have 9x on both sides. I subtract 9x. I subtract 9x. I have 2 less than or equal to negative 12. No variables. So that means, again, I have to ask myself, am I dealing with a true statement or a false statement? 2 less than or equal to negative 12. That is false. That is not the case. So that means that there is no solution here. Now, I did all this on the far left-hand side to make a point. Let's keep the same problem for the most part, but change my inequality from less than or equal to just greater than. So I'll have 9x plus 2 greater than 9x minus 12. Subtract my 9x's. Subtract my 9x's. 2 is greater than negative 12. Again, I got to ask myself, is this a true or false statement? And this is where inequalities are a little bit tricky. With an equation, both of these, end of story, no solution, because 2 and 12 don't equal each other. But we don't need them to equal each other. We just need it to be correct. Is it less than or is it greater than? Now that I've flipped my inequality here on the right-hand side with all the blue stuff, this is a true statement. So I have all real numbers. No matter what I plug in, I guess I should have used that fancy R there, this inequality will always be true. And so that's how we go about determining the number of solutions. And again, I want to just go back to the very beginning, over here, just to stress that we have 3 situations. More often than not, this is the one we're going to deal with. But occasionally you do run into a situation where you will get no solutions or you're going to get all the solutions. And it all hinges on it being true or false. Looking at what remains in the equation when the variables are gone, do the numbers form a true statement or a false statement? Good luck with your homework or practice, and let me know if you have any questions.